The National Electrical Code, specifically Article 392, addresses cable trays. Section 392.13.11, titled Number of Conductors Permitted, states that no more than 3 circuits shall be permitted to occupy a single compartment of a cable tray. NFPA 70E, the Standard for Electrical Safety in the Workplace, Section 130.5c, covers wiring methods. Paragraph 1, General, states that electrical equipment shall be connected by approved wiring method. Wiring methods shall be installed in accordance with the applicable requirements of Chapters 3 through 8 of this standard and other applicable codes and standards. Paragraph 2, Number of conductors in a conduit or raceway, says that the number of conductors permitted in a conduit or raceway shall not exceed the number for which the conduit or raceway is approved and shall not be limited by the provisions of the code or other applicable codes and standards. Paragraph 3, Conductors in enclosures, states that enclosures shall not be used as raceways. Therefore, considering these requirements, no more than 3 circuits, represented by cables, can be pulled through a single compartment of a cable tray or a seal fitting. In a specific scenario presented, using 18-gauge wire and a 3/4-inch seal, the code dictates that no more than 3 cables can be pulled through that seal. It is crucial to remember that these codes are in place to ensure electrical safety and proper functioning of electrical systems. Overfilling conduits or seal fittings can lead to overheating, insulation damage, and potential electrical hazards. It is paramount to adhere to these guidelines to mitigate risks and maintain compliance. While the NEC provides a framework, practical application can sometimes present unique scenarios. For instance, the type of cable used, its insulation rating, and the operating temperature can all influence the overall heat dissipation capacity of the wiring system. These factors may necessitate further dating or adjustments to the number of conductors allowed in a conduit or seal fitting. The NEC provides tables and guidelines for dating conductors based on various factors, such as ambient temperature and the number of current carrying conductors in a raceway. These dating factors must be applied to ensure that the conductors are operating within their safe temperature limits. In addition to the NEC, local electrical codes and regulations may also impose stricter requirements or have specific interpretations of the NEC. It is important to consult with local authorities or a qualified electrical inspector to ensure compliance with all applicable codes and regulations in the specific jurisdiction. For example, some jurisdictions may have specific requirements for the types of seal fittings allowed or the methods of sealing conduits to prevent the ingress of moisture or contaminants. These requirements are typically aimed at protecting electrical systems from environmental factors and ensuring their long-term reliability. When selecting seal fittings, it is important to choose fittings that are appropriately sized for the cables being used and that are listed and labeled by a recognized testing laboratory such as Underwriters Laboratories UL. Listed and labeled fittings have been tested to meet specific safety standards and are suitable for use in accordance with the NEC. The size of the seal fitting should be chosen to provide a tight, secure fit around the cables, preventing the ingress of moisture or contaminants. The fitting should also be made of a material that is compatible with the cables being used and the environment in which it is installed. For example, in corrosive environments, stainless steel or other corrosion-resistant fittings may be required. The installation of seal fittings should be performed by qualified personnel in accordance with the manufacturer's instructions and the requirements of the NEC. Proper installation is essential to ensure that the fitting provides a reliable seal and that the cables are protected from damage. When pulling cables through seal fittings, it is important to use appropriate pulling techniques and lubricants to avoid damaging the cables or the fitting. Excessive force or improper lubrication can cause the cables to become damaged or the fitting to become distorted, compromising the seal. It is also important to ensure that the cables are properly supported and secured to prevent them from pulling or straining the seal fitting. Cable support should be installed at appropriate intervals to prevent the weight of the cables from putting undue stress on the fitting. Furthermore, it is always recommended to consult with a qualified electrician or electrical inspector. The complexity of electrical installations and the potential for misinterpretation of codes necessitate expert guidance. An experienced electrician can assess the specific application, taking into account factors such as cable type, environmental conditions, and local code requirements to ensure compliance and safety. An electrical inspector, on the other hand, serves as an objective third party who can verify that the installation meets all applicable codes and standards. Their expertise can help identify potential issues and ensure that the electrical system is safe and reliable. The recommendation to consult a qualified electrician or electrical inspector is not simply a formality. It is a crucial step in ensuring the safety and integrity of electrical installations. Electrical work can be hazardous if not performed correctly, and even seemingly minor errors can have serious consequences. A qualified electrician has the knowledge, skills, and experience to perform electrical work safely and in accordance with all applicable codes and standards. They can also provide valuable advice on the selection of appropriate materials and equipment and the proper installation techniques. In addition to the NEC and NFPA 70E, other standards and guidelines may also be relevant to the installation of cables and seal fittings. For example, the National Electrical Manufacturers Association NEMA publishes standards for electrical enclosures and fittings. These standards provide detailed specifications for the design, construction, and testing of electrical equipment. The Institute of Electrical and Electronics Engineers IE also publishes standards related to electrical safety and performance. These standards cover a wide range of topics, including grounding, bonding, and surge protection. Staying up to date on the latest versions of these standards and guidelines is essential for ensuring that electrical installations meet the highest levels of safety and performance. Continuing education and professional development are also important for electricians and other electrical professionals. The electrical industry is constantly evolving, with new technologies and techniques being developed all the time. By participating in continuing education courses and attending industry conferences, electrical professionals can stay abreast of the latest developments and maintain their skills and knowledge. This can help them to provide their clients with the best possible service and ensure that electrical installations are performed safely and efficiently. Therefore, understanding and adhering to the NEC requirements for cable fill and seal fittings is crucial for electrical safety. The code limits the number of circuits that can be pulled through a single compartment, typically no more than 3. It is always recommended to consult with a qualified electrician or electrical inspector to verify compliance with all applicable codes and standards, as well as to consider factors such as cable type, environmental conditions, and local regulations. Failure to comply with these requirements can lead to overheating, insulation damage, and potential electrical hazards. In summary, firstly, refer to NEC Article 392 for cable tray requirements. Secondly, note that Section 392.1311 limits the number of circuits in a single compartment. Thirdly, NFPA 70E Section 130.5c provides general wiring method guidelines. Fourthly, understand that no more than 3 circuits should pass through a seal fitting based on the NEC. Fifthly, consider factors like cable type, insulation, and operating temperature. Sixthly, consult local electrical codes and regulations for stricter requirements. Seventhly, choose appropriately sized and listed seal fittings. Eighthly, ensure proper installation by qualified personnel. Ninthly, use proper pulling techniques and lubrication. Tenthly, support and secure cables to prevent stress on the fitting. Finally, always consult with a qualified electrician or inspector for verification and guidance. By following these steps, electrical installations can be performed safely and in accordance with all applicable codes and standards. Remember, electrical safety is paramount, and proper planning and execution are essential for preventing accidents and ensuring the long-term reliability of electrical systems. In addition, it is important to consider the potential for future expansion or modifications to the electrical system. When installing cables and seal fittings, it is wise to leave some spare capacity to accommodate future needs. This can help to avoid the need for costly and disruptive rework in the future. For example, when selecting a seal fitting, it may be beneficial to choose a slightly larger size than is currently required to allow for the addition of future cables. Similarly, when installing cable trays, it is important to consider the potential for future expansion and to ensure that the tray is sized appropriately. By planning for the future, it is possible to create an electrical system that is flexible, adaptable, and capable of meeting the evolving needs of the facility. Furthermore, it is important to document all electrical installations accurately and thoroughly. This documentation should include detailed drawings, specifications, and test results. Accurate documentation can be invaluable for troubleshooting problems, performing maintenance, and planning future modifications. The documentation should be stored in a safe and accessible location and should be updated whenever changes are made to the electrical system. In addition to the technical aspects of cable fill and seal fittings, it is also important to consider the human element. Electrical safety training is essential for all personnel who work on or around electrical equipment. This training should cover topics such as hazard identification, lockout/tagout procedures, and the proper use of personal protective equipment. By providing employees with the knowledge and skills they need to work safely, it is possible to reduce the risk of electrical accidents and injuries. The electrical safety is a shared responsibility, and everyone has a role to play in ensuring a safe working environment. It is important to foster a culture of safety in the workplace where employees are encouraged to report hazards and to speak up if they see something that is not right. By working together, it is possible to create a safer and more productive workplace for everyone. In conclusion, the NEC requirements for cable fill and seal fittings are designed to protect electrical systems from overheating, insulation damage, and other potential hazards. By understanding and adhering to these requirements, and by consulting with qualified professionals, it is possible to ensure the safety and reliability of electrical installations. Remember to consider all relevant factors, including cable type, environmental conditions, local regulations, and the potential for future expansion. And above all, prioritize electrical safety and foster a culture of safety in the workplace. The requirements discussed are not merely suggestions. They are codified standards intended to protect people and property from harm. Ignoring these regulations can have serious, even fatal consequences. Therefore, due diligence in understanding and implementing these codes is not just a matter of compliance, it is a matter of life safety. The 3-circuit maximum applies regardless of the voltage of those circuits. Whether the circuits are low voltage control circuits or higher voltage power circuits, the limitation remains. This is due to the potential for heat buildup within the confined space of the seal fitting. Overcrowding the fitting with too many conductors restricts airflow and can lead to elevated temperatures, potentially damaging the insulation of the wires. It is also important to recognize that the NEC is a living document, constantly being revised and updated to reflect new technologies and best practices. The electricians and other electrical professionals must stay informed of these changes to ensure that their work is always in compliance with the latest regulations. Subscriptions to professional organizations, attendance at industry seminars, and regular review of NEC updates are all important for staying current in the field. Proper grounding and bonding practices are also critical for electrical safety. Grounding provides a low impedance path for fault current to return to the source, helping to trip circuit breakers or fuses and prevent electrical shock hazards. Bonding ensures that all metal parts of an electrical system are at the same electrical potential, minimizing the risk of shock. The NEC contains detailed requirements for grounding and bonding, and these requirements must be followed carefully to ensure electrical safety. Furthermore, surge protection is an important consideration for protecting sensitive electronic equipment from damage caused by voltage surges. Voltage surges can be caused by lightning strikes, utility switching, or other electrical disturbances. Surge protective devices (SPD) can be installed at the service entrance or at individual equipment locations to divert surge current away from sensitive electronics. The NEC contains requirements for the installation of SPD, and these requirements should be followed to ensure effective surge protection. In addition to the NEC, other codes and standards may also be relevant to specific electrical installations. For example, the International Building Code (IBC) contains requirements for fire protection and life safety in buildings. The International Mechanical Code (NEC) contains requirements for mechanical systems such as heating, ventilation, and air conditioning. The National Fire Protection Association (NFPA) publishes a wide range of codes and standards related to fire safety. It is important to be familiar with all of the codes and standards that apply to a particular project and to ensure that the electrical installation is in compliance with all applicable requirements. Finally, remember that electrical work is inherently dangerous, and it should only be performed by qualified and experienced personnel. If you are not comfortable working with electricity, it is best to hire a qualified electrician to do the work for you. This can help to ensure that the work is done safely and correctly and that the electrical system is in compliance with all applicable codes and standards. The NEC provides a framework, but practical application requires expertise. An electrician can assess the specific installation and ensure compliance. The recommendation to consult a qualified electrician or electrical inspector is not simply a formality. It is a crucial step in ensuring the safety and integrity of electrical installations. Electrical work can be hazardous if not performed correctly, and even seemingly minor errors can have serious consequences. A qualified electrician has the knowledge, skills, and experience to perform electrical work safely and in accordance with all applicable codes and standards. They can also provide valuable advice in the selection of appropriate materials and equipment and the proper installation techniques. Therefore, always err on the side of caution when it comes to electrical work and seek the assistance of a qualified professional when needed.